Isabella step out for a minute?
She's here.
Okay, folks, first off, those out there at home, can you just, turn the cameras on so I know you hear me? Okay, there's one, he can hear me. Okay, thank you, Shayna, excellent. All right, so the do now is on Moodle. It's 6 problems. 3 of them are circle problems like we did last class. 3 are distance formula problems. I'm actually gonna put the distance formula right on the board for you. And there you have it. I don't know if you can see that, but I hope you can. Does anybody have questions about what we're doing right now? Okay. Oh. Move. Vote.
Oh, wait.
So,
Yeah.
Okay, we need more time. Okay, so like another minute or so. How we doing out there,
I'm good.
Shayna and Ethan?
I'm good too.
Thumbs up, thumbs down? I didn't hear anything. Maybe you're muted. Awesome. Cool. Thanks. Yes.
So I was off by like 15.01. Yeah, because I did 1 plus.
-5 and 2. Great. All right, so distance equals square root of 3 minus 2 squared plus -5 minus 8 squared. Squared. 1 squared plus -13 squared. 1 plus 1 is 69. Did you add this wrong?
I think I did, because I got, yeah, I got 12 instead of.
Then that would be, does it show you what the answer is?
Yeah, it's 13.04.
Yeah, that's about. Um, does anybody else need more time? You good? Okay, so I think everyone's done. So does anybody have any questions on this stuff? How'd you do on the circle ones? That's the big thing. How'd you do on those circle ones? 3 for 3?
I kept forgetting to do the.
Square root. Square. Wait. The square root of the right, of the side, the right side? Okay. Anybody else? Okay, can you guys put your laptops away? Not you guys, but you guys put your laptops away. Oh, no battery. Hold that thought. Hopefully this will work. Okay, so you guys are gonna have to bear with me out there. Can you hear me, like just as I'm talking though?
Yeah, I can hear you.
Okay, awesome. Okay, so with this circle stuff, the circle stuff itself doesn't get any more challenging. There's no like extra formulas you have to learn or anything. But in order to solve more complex problems with circles, I'd like to review a few things you learned in Algebra 2 that you're going to need to be good at. Okay. The first thing is slope. You probably learned that in Algebra 1, right? Slope. Not just like slope in general, which is rise over run. I think you guys know that for a line. But if I have a line that has a slope of 3/4, okay, what is the slope that's perpendicular to that? Okay, awesome. You both got it. So the perpendicular slope is -4/3. So not only do you flip it upside down, but you also change the sign. So that means if I have a line that goes this way, right? Call this line 1. The line that goes this way has an opposite reciprocal slope. So if this slope here is 3/4, this one is -4/3. Okay. And that means that this creates a 90-degree angle. Okay, so this is just review. So if you're looking at the same, well, duh, of course, it's because it's review and you've seen it before. But I just want to make sure that you're clear that it's not just the opposite. It's not just -3/4, and it's not just the reciprocal. It's not 4/3. It's both the opposite, so you change the sign, and the reciprocal. Okay. Cool. Are you guys good with that out there?
Yeah.
Okay. You can just give me like the hand wave if you,
Oh, okay.
which is fine. Shayna? Okay, there you go. The other thing is called point slope form of an equation. Who knows what point slope is? This is review, but this one gets confused with a few other kinds of equations. What do you think? So that's not point slope. What you're thinking of is slope intercept. Y equals mx plus b, right? It's not that one. Does anybody remember what the point slope equation is? Okay, then this is good that we're reviewing it. So this is used when you know a point and have a slope and want an equation. So if you know a particular point like 3,5, and you have a slope like 4/3, you can create the equation for a line using this simple formula, and you just have to plug in some numbers here. It is y minus something equals x minus something, and those somethings are y1, m, and x1. So if you know a point like 3,5, I guess I'll use that one again. and you know a slope, like 3/4, you can just plug these things in to this form of the equation, and you'll have an equation that will create a line that goes through that point with that slope. And it would look like this. In this case, it's y minus 5 equals 3/4, and x minus 3. Because I used the point slope form of the equation, it's guaranteed that this line is going to pass through the point 3,5, and it's going to have a slope of 3/4. Clear?
You add the 5.
So you could add the 5 to the other side if you wanted. But this is fine the way it is. Yes.
If you rearrange it, wouldn't you just get the y-intercept?
Yep. If you rearrange this, you'll get the slope intercept form. So you'd be able to see the where the y-intercept is and the slope. But you don't have to do that. That's more math than you need to do. So her question was, if you rearrange it, you get y equals mx plus b. The answer is yes. You don't necessarily always have to do that. And it's tough to immediately just think of the y equals mx plus b version of the equation if you know a point and a slope. Like if I said I wanted to go through 7/11 and have a slope of 5/12, you can't just jump right to slope intercept. You'd have to go through this first because you can just plug the numbers into this. Do you know what I mean? Okay. There is one case where I could jump right to that. If I know that it passes through 0, 0, or actually 0 anything, it has a slope of like 5, 7. This is a y-intercept because this is on the y-axis, right? So I could just write y equals 5/7x plus 8.
But if you have the slope, couldn't you use the slope to find the y-intercept using the slope-intercept line?
Yep. Yes, you could. But I mean, there's a lot of different things, ways you can manipulate this. I'm not sure. It depends on what you're trying to do, I guess. But this is the one that we need for this. Okay. Hand wave out there in cyberspace. You good, Shayna? Okay. Is this a good enough refresher for you guys? Okay. All right. Next, systems of two equations. Ooh, it's a big deal. Does anybody recall anything about solving systems of equations here?
Is one called like sublimation?
So there's different ways to solve systems of linear equations, yeah. But linear systems themselves just mean more than one equation. Like this. So this is a system of two linear equations. Sometimes they're called simultaneous equations. And there are many ways to solve them. There are many ways to solve them. And you probably learned at least 3 different methods in Algebra 2. My job is not to tell you which method to use to solve your linear system. Okay? That's Algebra 2 stuff. It's beyond the scope of this class. But I need to make sure that you can solve a linear system. Okay? Now, before I put this set of equations up here and I said linear systems, I got a few blank stares back at me. Once I put this up here, do you now know what I'm talking about? You don't know how to do them? Okay. Anybody else? Do you mean, no, you don't remember how to do them, or no,
I
no
don't
one
remember
else?
how to do them.
Okay. Okay, how about out there? Can show me, give me a hand raise if you remember how to do this, if you do remember. Okay, no hand, okay, got it. Whew. There's a lot of different ways. I'll show you like the most basic way that always works. Okay, that's pretty easy. I'm going to use linear combinations. Okay, have you heard that phrase before? Linear combinations. Okay, all right. Basically, what we want to do, well, first off, these are two lines on a coordinate plane, right? And they intersect. Hopefully, they intersect at some point. Which means that this x and this x are the same x because they're on the same coordinate plane. And this y and this y are the same because they're on the same coordinate plane. So we can actually manipulate one of these equations. And I think once I start doing it, you're going to say, oh, I remember doing this. I'm going to try to eliminate one of those variables by combining the equation. All right. In fact, what I'm going to do is I'm going to take that second equation and multiply it by 4. And then add that whole second equation, the new one that I multiplied, to the first one. And you'll see what happens. So I'm just going to rewrite this one here. 3x plus 4y equals 10. And then I'm going to multiply this one by 4. 20x minus 4y equals 36. Does anybody know why I multiplied it by 4? What do you think, Danielle?
We'll cancel off the 4y.
Yeah, because when I add them together, 4y minus 4y is going to be 0. And then I'm just going to be left with one variable, which I can solve for. Okay? Do you remember doing this now? Do you remember doing this now, Molly?
Oh, I always do it.
Oh, you did? Okay. You didn't say something. You didn't speak up or anything.
Well, you asked people who didn't know.
Okay. So you do remember how to do this?
Yes.
Okay. I didn't see like any, like, oh yeah, like usually I get like a head nod of a couple of folks who do know how to do it. So what happens when I add these together then? Okay. What else?
And the 3x and the 20x becomes 23x.
Right. So if I add these two, I get 23x plus 0y equals 46. So now I have this new equation. Thank you. So I have this new equation here. 23x plus 0y. I don't need to put that 0y, right? It's just 23x equals 46. So what does x equal? 2, because you divide both sides by 23. So can you give me a show of hands if you remember how to do this now? Like, so most folks, you never saw this? Okay. Do you see what I'm doing here though?
Yeah.
Okay, yeah.
And I was 2 times y.
So you totally could do that. So she's saying take this x and put it back into one of these equations to find y. So 3 times, it doesn't matter which equation. So I'm going to plug that x in, that 2 into the x to get this, which gives me 6 plus 4y equals 10. 4y equals 4, y equals 1. I think I kind of went off the board there. So that's one way to do it. So now I know my solution is 2, comma 1. That's the solution to this system. That's where those two lines intersect. Do you guys recall any other methods to do this other than linear combinations? Those of you who do remember, what would you do?
Maybe like plug the equations into one another.
Yep.
So you would like, you could take the 5x minus 1 into 9, you could rearrange the.
Yes, you could. Yep, then that totally works too. And what she's saying is you essentially take one of the equations and solve it for a variable and then plug that into the other one. I never think to do it that way, but like if I made this 5x minus 9 equals y, this one, I could then take this and plug it into the y of the other equation. And that would give me the same result. Does anybody remember a different way? Like setting the equations equal to each other? Or using a matrix? Determinants? There's lots of different ways to do this. Okay. You need to be, the expectation is that you can solve a system using a method, doesn't matter which one. So if you need some resources for that, you got to let me know, okay? But basically, that's how you do it. Review of that. Okay, so now that those kind of basic algebra skills have been just kind of lightly reviewed, I want to put the standard form of a circle equation. That's the standard form. And the distance formula. Up here. You're going to need these, so jot them down if you don't have them committed to memory. Okay? Just to make sure that we're all on the same page here, can you solve this system with two linear equations? I'll move out of the way. It's right there. I'm gonna pull up another problem.
James, the Thomas, please report to the main office.
What method did you use? What'd you get?
I don't know. Can you just do it on the board except for
Sure, which method did you use?
the one you
Okay. Did you multiply either one of these by anything first?
by 2y by 3 and 3y by 2.
Okay, so this whole equation, not just this, but the whole equation by 3,
Just,
that's why.
but I multiplied the 9. By
So you just did these two numbers, you didn't multiply this one by 3? That's what happened. You have to multiply the whole equation. Okay, how did we do out there? Did you guys get what, negative 1, 3?
Yeah.
Awesome. Yes, Tim?
I got 1/6.
1, 6. Okay, so I know what happened. I think you found x first.
Yeah.
Okay, you found x and you messed up the sign, and then when you plugged it in, you got the wrong value. So go back to your work for when you found x. It looks like you probably multiplied this one by 5.
Oh, I see what I did.
Okay,
No, I did. Wait, so no, I don't understand how you got the. Wait, no, yeah, I did.
you had it's negative 1, not 1.
I did, yeah, I know, yeah, never mind, I know what I did.
What'd you do?
I did, so when I did the first part, or once I like multiplied the top, by 3, like the whole equation by 3 and the bottom equation by 2. And I ended up getting like 19x, it should have been 19x equals negative 19, but I just did 19x equals 19.
19.
Yeah,
Oh, okay, yeah,
so I did x equals 1 instead of x.
right. So you found x for yeah, and then when you plugged it in, it gave you the wrong value. Okay. Abby, were you able to get it? Okay. So what variable as a class do you think we should solve for first, x or y? X, y, is there a reason or just kind of random? Oh, okay,
Also, it just makes more sense. It would be a smaller. So you have to multiply.
okay. For me, the reason I would probably solve for x first is because this one is already negative, and then I have to worry about negatives, but you don't really need a reason to solve for one or the other. It just, since this y, this is negative 2, if I multiply the top one by 3 and the bottom one by 2, I don't have to worry about negatives. They're just going to cancel out. So 9x minus 6y equals negative 27. Is that what it is? Yeah. And then 2 is 10x plus 6y equals 8. 19x equals negative 19. So x is negative 1. Abby, you need a calculator?
Not any.
What, were you able to get negative 1, I mean? So did you get negative 1, 3? Okay, good. Anybody else want me to go through this? Okay, then I guess we'll move on. Okay, so now this bigger kind of problem or more complex problem that you might see involves all of these different things. For instance, you might have a circle with a center at, what do I have? Negative 6, 1. And a tangent line of 7x plus 2y equals 66. Find equation of circle. So I think the first thing that jumps out at you is, well, what's a tangent line? The word tangent. Does anybody know what a tangent line is? What is it? Yeah, it just intersects once with the circle, which means it does something like this. Okay. So I know that this is at negative 6, 1, and I know the equation for this line. Well, if you think about the standard form equation for a circle, there's only 3 parts to it. Really only 2. The center, which is this stuff, and the radius. Well, we know where the center is, right? So most of this equation is kind of already done for us. In fact, I could do it just by filling in the numbers. X minus negative 6 squared plus y minus 1 squared equals something. And of course, negative 6 would make plus 6. So half of the equation is done. I just need to find this radius, right? Well, what's interesting is, since this tangent line touches in exactly 1 point of the circle, at that particular point, if I draw a perpendicular line to this, it's going to go through the center of the circle. It has to. Which means if I find the slope of this line, then I'm good to go, because I can actually create an equation for this line, right? You know what I mean? Because I have a point and I'll have the slope. You follow what I'm saying? So if I have 2 equations that intersect on one coordinate plane, I can find where they intersect by solving that linear system, which would tell me this coordinate, right? So if I know this coordinate and I know this coordinate and I need to know the radius, I can use the distance formula to find it. Okay? That's my logic behind this. So first, let's find the equation of this line. I've already got this one here. What do I need to do? Flip what? Not exactly. But we have to flip something and change its sign.
I was gonna say good.
Sure, okay. Put it in y equals mx plus b. That's a good first step. Let's see, that would be 2y equals negative 7x plus 66, or y equals negative 7 over 2x plus 33. What does that form tell us? What's the first thing after the equal sign? It tells us the slope, right? That's the slope of this line here. This line is perpendicular to it. Right? So what's the slope of this line? If the slope over there is -7/2, you're right. Yes. Yeah, what's up?
Switch for the 66 one,
I didn't move the 66. Then the 7x. I said this, I did -7x from both sides. Get this. So what's the slope of this line? 2/7, right? So now I know a point and a slope. So if I put that into point slope form, I'm gonna write that up here. Y minus y1 equals m times x minus x1. I can come up with an equation for this one. So y minus, looks like 1 equals m times x minus -6, or actually x plus 6. That's the equation for this line. Right? Now, when we solve systems of equations, depending on how you solve it, you may want to format this. You may want to jumble it around to make it easy to solve with this one. Because we know that 7x plus 2y equals 66. And for this one, if we want to put it in that same form, I would probably multiply everything by 7 to clear the denominators. And make this 2x minus 7y, maybe 7 minus 12, equals -19. So there's my new system of equations.
When you're multiplying numbers by how come you didn't multiply by the stuff inside the parentheses?
Because this is one term. If you multiply, like, this is this times this, right?
Yeah, so then it would be.
Yeah, so you don't do like, if you want to multiply this by 5, you don't do 5 times 2 times 5 times 3. You just multiply one of those.
Okay.
So if I solve this system, I'll have the location of this point. Let me just stop here for a second. There's a lot going on, and you need to apply lots of different things that you learned in Algebra 2 and Algebra 1 and Precalc. Is everybody with me so far, or is anybody starting to get lost here? Yeah, that's what I'm doing. Good. While on pause, solve this system. That will give you the coordinate.
So we used the point slope, sorry, what was the point of using the point slope formula?
Because we knew a point
Yeah.
and a slope.
Right, and then that gave us just the equation of the line,
That gave us this equation, yeah.
but we already had the equation.
No, we had the equation for this line. So that slope that we used was the perpendicular to this one. So
Right,
you had to find the slope for this one. But we need the second equation. And we know that it's gonna go through this point, because we wanna find the length of this.
when we did when we found the perpendicular slope,
Mm-hmm.
they're gonna have different y-intercepts though, right?
Yes,
Oh, okay. That's what I
so we just know the point and the slope, we don't actually know. It can't be just any perpendicular line, it has to be a specific one. Let me see if I can find the.
And finding the solution, what would that give us?
This point.
Oh, right, okay.
Did you get one?
Then you use the distance one.
You got it. Because you need that radius. Now you're probably gonna get like the square root of some number. But in the equation itself, we want the radius squared.
So then
Then you want to do the square root, yeah. So was everyone able to get 8, 5 for their coordinate? That's the solution to that system. Questions on how to get 8, 5? We're good? 8, 5? Okay. So then we use the distance formula to find the length of this radius. Distance equals the square root of -6 minus 8 squared plus 1 minus 5 squared. Distance equals the square root of 14 squared is 196 plus 16. Distance equals the square root of 212, which means the radius is 212, or the square root of 212. But we need the radius squared, so it's just 212. So it uses all different aspects of algebra to solve this kind of problem. I'm gonna leave this up here for a minute, or for the rest of the class. But I'd like you to open up Moodle, because there's one of these problems for you. Right in the beginning of the section. If you would like to work together, by all means, so please just kind of stay somewhat distant. Did you guys hear me out there? There's one of these on Moodle for you.
Yeah, thank you.
No problem. And I don't know if I can actually do this. I'm gonna try to zoom out for you a little bit. And so I've just recorded that whole thing there. So I'm gonna send this link out to you guys once the recording gets processed by YouTube or whatever. And then you'll have like a walkthrough of how to do this problem.